Good morning, happy Tuesday. All right, here we go. This is 8-6, kind of putting it all together. So factoring polynomials. The first thing that you need to figure out is, do you have a GCF? For example, if I have 6x squared y plus 10xy squared, is there a GCF that I can pull out of there? Yes, there is. So I can pull out a common factor of a 2 and an x and a y. When I do that, I'm left with 3x plus 5y. So that's the first thing that you need to look for when you factor any polynomial. Does it have a GCF? If yes, factor it out. If no, then you have to move on. So when you move on, you have a couple choices. You have, is there 2? Is it a binomial? You have a choice of, is it a trinomial? And you have a choice of, is it a polynomial with 4 or more terms? So that's where you go. So if it's just a binomial, then we're going to look at one. So x squared minus 9y squared. So when you do the binomials, you see if you can find the difference of the squares. If yes, we need to factor it out. So is this a perfect square? Yes. Is this a perfect square? Yes. So I know that x is a perfect square. I'm going to put 1 in each. I know that 9 is a perfect square and y squared. So 3y, 3y. That negative, remember, tells me that 1 is positive and 1 is negative. So that when I factor it out and multiply it out, I'm going to lose that middle term. So that's a difference of squares. So I factored it out, and I'm done. If we're talking about a trinomial, then we have a couple questions to ask. First of all, is it a perfect square trinomial? If yes, then I need to factor it into a minus b squared or a plus b squared. If no, then I need to see if I can factor the trinomial. If yes, I need to factor it. If no, then it's unfactorable. So let's do an example of a trinomial. So we'll do x squared plus 4x plus 4. So is that a perfect square trinomial? Well, let's see. That's a perfect square. That's a perfect square. So I have x and x, and I have 2 and 2. 2 plus 2 is 4, so that works. And they're all positive, so x plus 2, or I could say x plus 2 squared. So yes, that's a perfect trinomial. I could have had a different one. I'll use a different color marker so you can see it, which is x squared minus 2x plus 1. X squared is a perfect square, and 1 is a perfect square. So x and a 1, x and a 1. So they're both the same, and they're both negative. So x minus 1 squared. I could have had one that's not a perfect square, which could look like x squared plus 3x plus 2. So I could do my diamond situation here, and I have product of 2, the sum of 3. So when I do that, I know it's x, and a 2 and a 1, and they're both positives, so that's my answer. And I'll give you one more trinomial. 6x squared plus 7x plus 2. So my diamond puzzle, 6 times 2 is 12. I have to make it add up to 7. So I have a 3 and I have a 4. So I have 6x squared plus 3x plus 4x. I'm going to run into this. 3x plus 4x plus 2. Remember this grouping? Factor them out. So I can pull out a 3x. When I pull out a 3x, I have 2x plus 1. And I pull out a 2 here. So I have 2x plus 1. 3x plus 2. 2x plus 1. Perfect. So I factored it out. It wasn't a perfect trinomial, but I could still factor it out. What if I have 4 or more polynomials? This is when you group them together. So here I have 2x to the third power plus 4x squared plus x plus 2. Remember, group them together. So 2x to the third plus 4x squared, I can pull out a 2x squared. I'm left with x plus 2. And that's already x plus 2, so I'm just going to pull out a 1, x plus 2. Put these two together, 2x squared plus 1 times x plus 2. Perfect. And that's it. So this is just, and you'll see that the resource is just for you guys to kind of organize everything from chapter 6. So first of all, figure out if you can pull out a GCF. If you can, you have to do that first. Then figure out if it's a binomial, trinomial, or polynomial with 4 or more, and then work through it. See if they're perfect squares, and if not, then just factor them out. And if you can't factor them, they're unfactorable. That's it. Thank you.